Your midterm exam is coming up, and you don't remember anything you've learned this year. Yay! Well, don't worry, I'm going to go over the most important topics that you're going to need to know for your Algebra 2 midterm. Alright, so here's the first problem that we'll be doing in this video, and I want you to start thinking about this problem while I quickly explain how this video is going to work. This video is going to have 10 problems, and they're all just going to be the basic things that you need to know for the Algebra 2 midterm. Now, obviously, every midterm is different, so make sure you check with your teacher or professor to make sure that you know what's going to be on the exam. So for this video, you're probably going to get the most out of it if you pause the video when I show each question and try to do it yourself first. And then you can unpause the video and see where you went wrong or what you did right. So let's get started with this first problem where we have to solve for x, and we have some numbers and x's here. Well, whenever you see something that looks like this, where we have a number in front of parentheses with pluses and minuses and stuff, this should immediately stay in your head. This is the distributive property. And what the distributive property means is this 2 in front here, it's being multiplied to the parentheses. And we have to basically multiply the 2 out to both parts of the parentheses. So to the 2x and to the 3, or the minus 3 actually, the minus sign stay. So we're going to have 2 times 2x first. 2 times 2 is 4, and then the x stays. And then we have 2 times 3, which is 6, and then the minus sign stays as well. And then that's just going to equal 5x minus 12. Now, we need to get x by itself, but it's kind of hard to get x by itself when x is on both sides of the equation, because we need it to be on one side. So what we're going to do is we're going to subtract one of these x's from the equation. Now, you have two options here. You can subtract 4x from this side, or you could subtract 5x from this side. I personally would subtract the 4x, because if you subtract the 5x, then you're going to be doing 4 minus 5, and you'll have negative numbers. And we like to avoid negative numbers as much as possible. So we're going to subtract 4x from both sides. Because remember, whatever you do to one side of the equation, you have to do to the other side. That's like the basic rule of algebra, right? So these cancel out. And on the left side, you're just left with not 6, minus 6. Remember, the minus signs stay. Equals. And then we have 5x minus 4x. We had 5 of them, and then we lost 4, so we only have 1 left. So you would put 1x, but you don't have to put 1 in front because that doesn't do anything. You can just put x, and then minus 12. And now we just need to get x by itself on this side of the equation. And the only thing in its way is this minus 12. So to get rid of it, we'll do the opposite of minus, which is plus. So we will add 12 to both sides. These cancel out. And on this side, you're just left with x. And on the other side, we have minus 6 plus 12, which works the same way. I know that negative numbers can get confusing, but remember, these are interchangeable. This is the same thing as saying 12 minus 6. And 12 minus 6 is 6. So our final answer is x is equal to 6. Now, for each of these problems, if you got it wrong or you're confused about something, I do have a longer video about each of these topics. So in the description, I have a link to the video that corresponds with each problem. So if you got it wrong, you can go ahead and review that video. All right, here's our second problem for the midterm review, and this is a graph-related problem. There's going to be a few of these in this video, but this one we don't actually have to graph anything. We just need to write the equation of this line. So how do we do that? Well, go ahead and pause the video and try it yourself, and then unpause and see how you did. All right, so the form for a straight line, and this is really important to know, so make sure you've got this down. It's y equals mx plus b. And these are the dumbest letters in the world because m stands for slope, and b stands for y-intercept. So basically, to find the equation of this line, we just need to find out the slope and the y-intercept. So what are the slope and the y-intercept? Well, the y-intercept is where it crosses the y-axis. Remember, the y-axis is where all the y numbers are, the up and down. So this is y. This is the x-axis, the one from the left to the right. So where does it cross this y-axis? Well, if we start in the middle, to get to the graph, we have to go down 1, 2, 3. So right here is where it crosses. And because we went down 3, that means the y-intercept is minus 3. And now what about the slope? Well, slope is rise over run. So what we're going to do is we're going to pick out another point on this graph, but I would recommend picking out, you can pick out anything, but I would pick out a point like this one here, because it doesn't have any fraction numbers in it. It's right on the corners of these boxes. So to get from this point to this point, you have to rise 1, 2. Which means our rise is going to be 2. And it has to run 1. So the run is 1. And 2 divided by 1 is 2, because anything divided by 1 is itself. So our slope is 2. So to find the equation of this line, all we have to do is rewrite y equals mx plus b, but with the numbers that we know. So in this case, this is going to be, and we'll write it over here, y equals m, which is our slope we just found out is 2, so 2x, and then we have plus b, and the y-intercept, or b, is minus 3. But we don't have to write plus minus 3. That just means minus. So we'll have minus 3. So there we go. The equation of our line is y equals 2x minus 3. All right, here's our third problem for this video. Go ahead and pause the video and try it yourself. So we need to solve for x and y, and remember that you can solve for as many letters as you want as long as you have that many equations or more. So we can solve for both x and y, which is 2 letters, because we have 2 equations. Now, there are 2 main ways to solve this. You can solve it either using substitution or elimination, and either one is fine here. I'm going to do it using elimination, but you're free to use substitution as well. If you were to do substitution, you would basically just try to get a letter by itself and then substitute it in for the other equation. So elimination, the goal of that is to try to eliminate one of the variables from the equation, right? Our goal here is to add up these 2 equations and eliminate a letter, but we can't do that right now. So for elimination, the question that I always ask is, it would be really convenient if this number right here was what number? And people usually say, well, it would be really convenient if this was a 2, because we have minus 2 plus 2, and then they cancel out, and then we get rid of y. But we can't just put a 2 here and make it into a 2. But we can use the rule of algebra, which is you can do something to both sides of the equation. So we're going to multiply this entire equation by 2. So the top equation is just going to stay the same, 2x minus 2y equals 10. But this bottom equation, we're going to multiply everything by 2. So 3x, 3 times 2 is 6, so that becomes 6x. Y becomes 2y. And then 7 times 2 is 14. And now if we add together these 2 equations, you'll see that we have 2x plus 6x, which is 8x. And then these cancel out, minus 2 plus 2. And then over here on this side, we have 10 plus 14, which is 24. And now we just have a one-step equation to solve for x. We have 8 times x equals 24. So to get rid of this 8, we'll do the opposite of multiplication, which is division. So we will divide both sides by 8. These cancel out, and we just have x on this side equals 24 divided by 8, which is 3. So x is equal to 3. But this doesn't actually mean that we're done with the problem, because remember, we need to solve for x and y. Well, to do that, we can use either of these equations. In this one, y is by itself, so it'll be easier to use this one. So we're going to bring back this equation, but instead of x, we're going to put 3, because we know that x is the same as 3. So we're going to have 3 times 3 plus y equals 7. 3 times 3 is 9, so we have 9 plus y equals 7. And now we just need to get y by itself. So 9 is being added to y. So to get rid of it, we need to do the opposite of addition, which is subtraction. So we will subtract 9 from both sides. These cancel out. And on this left side, we're just left with y equals, and then 7 minus 9. Well, think of this as dollars. We had $7 and we spent 9. So we have 2 less than before. So it's going to be minus 2. So there we go. Our final answer is x is equal to 3 and y is equal to minus 2. Or if you wanted to write it the fancy way, you can write this as coordinates. And with coordinates, x always goes first. So it would be 3, negative 2. So that is our final answer. And as a reminder, if you were confused about that or got it wrong, I have a full video on it that you can watch in the description. All right, it's time for another graph-related problem. We need to describe the end behavior of this weird graph. So if you think you can do it, go ahead and pause the video and try to do it yourself. All right, so what is end behavior? Well, shockingly, it's the behavior of the graph as it ends. And that should make you ask a good question, which is, doesn't this graph never end, right? It's got an arrow in it. It goes infinitely, which is exactly why end behavior has a bunch of infinity signs. I just realized, why is there an x here and not a y? Okay, hold on. So basically, there's 2 ways that this goes for x, or left and right. As x goes to the left, I know this is going really far up, but it's also going to the left, and it's going to keep going to the left infinitely, and it's never going to stop. So this is going to be approaching what we call negative infinity, which means it goes infinitely in the negative direction. But x also approaches positive infinity this way, because it's just going to keep going to the right farther and farther until the end of numbers, which doesn't exist. So the whole point of end behavior is figuring out what is y doing, the up and down, as x does things, goes to the negative infinity and positive infinity. So we're going to phrase this as x approaches negative infinity, y is going to approach something, right? And then as x approaches positive infinity, y is also going to do something. So let's find out what that something is that y is going to do. So let's start with this. As x is approaching negative infinity, going farther to the left every time, right? What is y doing here? Remember, y is up and down. Well, it seems to be going up. It's infinitely going up. And up is positive numbers. So as x is approaching negative infinity, y is approaching infinity. So we're going to put infinity here. Now, what about on this side? Well, here x is approaching positive infinity because it's going to the right. So what is y doing? Well, y is going up and up and up. It's just going to keep going up for eternity until it runs out of numbers. So y is also approaching positive infinity. So there we go. Our final end behavior is as x approaches negative infinity, y approaches infinity. And as x approaches infinity, y also approaches infinity. There's a lot of infinity signs, but that's because the graph doesn't actually end. So there we go. This is our final answer. All right, so here's the fifth problem in this video. We need to describe the transformation of this equation and graph it. So go ahead and try this on your own, pause the video, and then unpause and see how you did. So the three types of parent graphs are y equals x squared, which is going to be a bowl shape like a parabola, right? We have y equals the absolute value of x, which is pretty similar, except it's a V shape. And then we just have our classic y equals x, which is just a straight line with a slope of 1, because this number in front is 1, because you can't see it. So that would just be a diagonal line going like this. So which one of these is it? Well, in this case, we have y equals, and then this stuff, but we have a squared here, which means our parent graph is going to be y equals x squared. So let's go ahead and get rid of these other ones. So you could just graph a parabola by going like this and being like, good, perfect, but I mean, we want to be a little more accurate than that. So just graph the numbers here when y equals x squared. So if x is 0, 0 squared is 0, right? Now let's say you put in 1 for x. If you put in 1, you would get out 1 squared, which is 1, because 1 times 1 is 1. So when you go 1 to the right, you go 1 up. And then finally 2 squared, if you go 2 to the right, you will get 2 squared. 2 times 2 is 4. So when you go 2 to the right, you go 4 up. So we'll go right here. And remember that parabolas are symmetrical. So when there's a point here, there's also a point here. It's like a mirror. This thing here is a mirror. And then this one will mirror image to right here. And now we can just go ahead and draw our bowl shape, and we'll do that like this. So this is saying that we need to transform this graph. So we need to describe the transformation and graph it. So the question here is, what is this minus 2 doing? Because that's the only thing that's different, right? Other than these parentheses, but the minus 2 is in the parentheses. So the important thing here is to understand what these plus and minus signs do. So for example, if I had y equals x squared, then let's say I added a plus 1 to this. We are adding 1 to y, which means, well, y is up and down. So the whole thing is going to go up by 1 squared. And likewise, if I was to do like minus 2, then the whole thing would move down 2 squares. So you would graph the same thing, but downward. But in this case, we have it inside the parentheses. The minus 2 is also being squared. And that means we need to either move it left or right. But when it's inside the parentheses, it's actually the opposite of what you might think. A minus sign in parentheses actually means going to the right, and a plus sign means going to the left. If you want to understand more of why that is, you can go ahead and check out the full video in the description. But all you really need to remember is that if it's in the parentheses, it's left or right, and it's the opposite of what you might think it is. So minus means to the right. So we need to move the entire graph 2 squares to the right. So we're going to move 1, 2 this way, and we will just plot each of these points the same way as before, but 2 to the right. So we'll have 1 here, because that's 2 to the right. We'll have 1 here, we'll have 1 here, and 1 here. and we'll go ahead and graph this. So there you go. This is our new graph, and this is the answer. This green line is actually just the parent graph. It's not part of the answer, but if the instructions say you need to graph the parent graph, then include this green line as well. And it also says here that you need to describe the transformation, which is simple. We moved it 2 squares to the right, so you would say right 2. That's it. That's all you have to do. So this is our final graph. All right, congratulations, you've made it halfway through this video. You've finished 5 questions out of 10, so keep it up. And yes, I know it's another graphing one, but I promise this is the last graphing problem of this video. So we need to graph this equation. And you might be asking yourself, well, what shape would this graph even be in? Well, this graph, because we have a quadratic form here, we have a squared part, an x squared, we have a normal x part that's not squared, and then we have a part that doesn't have x at all. This means it's a quadratic equation, and quadratic equations are always in the form y equals ax squared plus bx plus c. And just so you know, if these were out of order or you had some things on the other side of the equation, you can just rearrange it into this format and then graph it. So how are we gonna graph this, right? Well, first of all, we can graph our y-intercept, and the y-intercept is actually really similar to the y equals mx plus b that you might be used to for straight lines. And our y-intercept is just c. It's the number by itself without an x on it. In this case, that's not 1, minus 1. Remember, the minus sign is included. So we can just go ahead and right away plot a point right here, because it's where it crosses the y-axis, the up and down line. Remember, this is y and this is x. We have to start in the middle, and for minus 1, that means going down 1. So we would go down 1 to this point. But now here's the most important part that's going to help you plot a bunch of other points, and it's called the axis of symmetry. The axis of symmetry is basically our mirror image line from before. Remember that we graphed a bowl-shaped graph here. Our axis of symmetry is basically just the mirror in the graph. So this would be the axis of symmetry here. And you can use this to plot a bunch of points, because you can see that whenever you get a point over here, there's also a point over here. So how do we find our axis of symmetry? Well, the formula for the axis of symmetry, and this is something that you're just going to have to remember, it's always negative b over 2a. So in this case, we have to figure out b. B is not 2, negative 2. B is negative 2, but it's negative b. So that's negative 2, which 2 negatives make a positive, so that's just 2. And then 2a, well, that's 2 times what's a? Well, a is, there's nothing there. Well, remember, if you don't have a number in front of a letter, that just means it's 1. So a is 1. And 2 times 1 is 2. So we have 2 divided by 2, which is 1. So our axis of symmetry is, well, the axis of symmetry is a line. Technically, this is x equals 1. So our axis of symmetry, how we graph it, is we start in the middle, and because it's x equals 1, we need to go to the right 1. And right here, we're going to draw our line. This is going to be where the axis of symmetry is. Now, this axis of symmetry doesn't just tell us where it's a mirror image, it also tells us where the bottom of the bowl is. Because remember, when we have a bowl-shaped graph here, we have our axis of symmetry. The bottom of the bowl is always on that line. So to find it, all we have to do is plug in 1 for x, because remember, x is 1 on this entire line. We need to plug in 1 back into the equation and see what we get for y, and that'll tell us where to put our point on this graph. So we're going to take this equation, and we're going to do y equals x squared now becomes 1 squared, because remember that x is 1, minus 2 times x is 1, and then minus 1. So 1 squared is 1 times 1, which is 1, minus 2 times 1 is 2, minus 1. And now we have to do it left to right. So 1 minus 2, we gained $1 and then lost $2, so we're down $1. So negative 1 minus 1, we lost $1 and then lost another $1, so that's minus 2. So in this case, y is equal to minus 2. So on this red line, our bottom of the bowl is going to be we'll start right here at y equals 0 and go down 1, 2. So we're going to have a point right here. Now, to get the most accurate parabola, we need to have 5 points, which seems like we have to do a lot more to get the rest of the points. But there's an easy way to get another point here. Remember, this is a mirror image. So if we have a point right here, there also has to be another point on the other side of the mirror. So this is 1 square away from the mirror. So 1 square away on the other side is another point. So now we have 3 points, and all we have to do is figure out one more point, do its mirror image, and then we have 5 points. So I'm going to pick out whatever point is going to go here on this line here, because why not? So on this line, we know that x is equal to 3 because, well, right here, we have to go to the right 1, 2, 3 to get here. So x is equal to 3 here. And to figure out where to place the point here, we'll do it the exact same way as we did with the axis of symmetry, the red line. So we're going to plug in 3 into this equation and see what we get. So we're going to have y equals 3 squared minus 2 times 3 minus 1. 3 squared is 9 because 3 times 3, minus 2 times 3, which is 6, minus 1. 9 minus 6 is 3, minus 1 is 2. So y is equal to 2. So on this part here, where x is 3, we need to go up 1, 2. And we're going to have a point right here. Now we have 4 points, and we only need one more. And that's easy. Remember that this is a mirror image. So this is 2 away from the mirror. So 2 away on the other side of the mirror is going to be another point right here. And now we have all the points that we need. So we're going to go ahead and draw the bowl that connects all these points. So yes, I know this is the worst bowl that I've ever drawn, and it's really messy, but it's fine. This is our final graph of y equals x squared minus 2x minus 1. Alright, congratulations, you have finished the graphing part of this video, which, if you're like me, is really good news. But we're not done with quadratic equations, because you can still solve quadratic equations without graphing. And there are tons of ways to do that, but in this case, we need to solve it by factoring. So go ahead and pause this video, try to solve it for yourself, and then unpause and see how you did. All right, so how do we factor? Well, if you don't have a number in front of here, like let's say we're ignoring this number, we would have to find two numbers that add up to the number in front of x and multiply to get the number that's not next to x. But in this case, we do have a number next to x squared, which means we have to do it a slightly different way, and it's called the x method. Now, there's a chance that your teacher or professor is teaching you a way other than the x method, and in that case, you can either just do it their way, or you can ask the teacher if you can use the x method, because in my opinion, this is the easiest way to understand it, but it's totally up to you. So first of all, we need to multiply what's normally our multiplying number, the number that we have to multiply to, and do it times the number in front of x squared. We have 2 times 3, which is 6, and then we have 1 minus sign, so minus 6. So this is going to be our new multiplying number. And then our adding number is still going to be the same. It's going to be plus 5 here. So we have to add to 5. So we need to find two numbers that multiply to negative 6, but add up to 5. How do we do that? Well, let's go ahead and find the factors of 6, and we'll go ahead and ignore the minus sign for now. So first of all, there's the obvious one of 1 times 6, right? 1 times 6 is 6. But to get negative 6, we need to make one of these negative, because remember, if one of the numbers is negative, then the negative carries over. But we can also tell that the negative number will always go on the smaller number because we are adding to a positive number. If we were to make the bigger number negative, we would always add to a negative number, and we need to add to a positive number. So in this case, we're going to make the 1 the negative number here. So negative 1 times 6 is negative 6, but if we add negative 1 and 6, well, that's the same thing as 6 minus 1, which is 5. And that's the number we are looking for. So we found our two numbers, negative 1 and 6. So what we're going to do is we're going to take those two numbers and put them on the sides of our x. So we're going to have negative 1 and 6. Now in normal factoring, what you would do is just take those two numbers and put them in, negative 1 and 6, and then give yourself an equation and then solve it. But in this case, we have a 2x squared. So we're going to have to do one extra step. What we need to do is take this number 2 and divide either of these two numbers here on the sides by 2. You can divide the negative 1 by 2, but then you have fractions and no one wants to do that. So we're going to divide the 6 by 2 instead. And 6 divided by 2 is 3. So our two numbers are actually negative 1 and 3. So we're going to do it the same way. We're going to put negative 1 and plus 3. But in this case, we have a 2x squared, which means one of the numbers in front of here isn't going to be x, it's going to be 2x. And it's always going to be the one that's the opposite of the parentheses where you divided by 2. I know that was confusing, but let me show you. In this case, we divided the 6 by 2 to get 3. So this number here, we divided by 2 to get to this number. So we need to put 2x on the opposite parentheses. So this one right here. And this one is just going to stay as x. And the reason that we do that is because if we were to do FOIL, which is how you go from this back to this, we have to follow the steps of FOIL. So first is f, which is first, and that would be 2x times x. That's why we did this in the first place, to get 2x squared. But then you have to do outer, and outer is the outer ones here. So 2x times 3. So that is why we do the opposite parentheses, is because in FOIL, we have to multiply the outer ones, and we get 2x times 3. So the last thing we can do here to solve for x is recognize that this is being multiplied to get 0, and anything times 0 is 0. So if just 2x minus 1 is 0, the whole thing is 0. And likewise, if x plus 3 was 0, the whole thing would be 0. So we can split this up into two equations. So we'll have 2x minus 1 equals 0, and we'll have x plus 3 equals 0. And just a reminder that you can only do this if it equals 0. So we're going to solve for x in this equation. We can get rid of the 2 or the negative 1. Let's get rid of the negative 1 first because it's less attached to the x. If we divided everything by 2, we'd have fractions, and no one wants to do that. So we're going to add 1 to both sides. These cancel out, and on this side, we're just left with 2x. And on the other side, we have 0 plus 1, which is 1. And now we just have a one-step problem. And this is multiplication, because whenever you don't have a sign, that means multiplication. So we'll do the opposite of multiplication, which is division. We'll divide both sides by 2. These cancel out, and you just have x equals 1 over 2, which is 1/2. So 1/2 is one of our answers. And now on the other side, we have x plus 3 equals 0. Well, this one's a little bit easier because it's just one step. We have a plus 3, so we need to do the opposite of plus, which is minus. So we'll subtract 3 from both sides. These cancel out, and we just have x equals 0 minus 3. This 0 isn't doing anything, so it's just minus 3. So our two answers are 1/2 and minus 3. Or if you wanted to write it the fancier way, you can do x equals and then these fancy little bracket thingies, which are what you use for a set of numbers. And normally you'd put it from least to greatest. So we'd have minus 3, 1/2. So our final answer is x is equal to negative 3 and 1/2. All right, here's problem number 8 out of 10. We're almost there. And we need to do the same thing. We need to solve for x. It's another quadratic equation. But in this case, we need to use the quadratic formula. So go ahead and pause the video, try your best to do this, and then unpause and see how you did. All right, so the quadratic formula is that formula that you can basically only remember if you use it a million times or if you listen to the quadratic formula song, which you can go ahead and watch that after this video. You're going to stay here. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So how do we even use this? Well, we're going to use it the same way as before when we had the form, if you remember from last time, ax squared plus bx plus c. So what is a? Well, a is going to be equal to whatever's in front of x squared, which in this case is, well, there's nothing here, but that means it's 1. So a is equal to 1. B is the number in front of x. And remember that it's not necessarily going to be in this order every time. You might have to rearrange the equation around. But in this case, b is going to be negative 4. Remember, the negative sign stays. So b is negative 4. And then finally, c is 8 here, positive 8. So to use the quadratic formula, all we have to do is plug these numbers into the a, b, and c and see what we get. So we're going to have negative b is negative 4, so negative negative 4, which is just positive 4, plus or minus the square root of b squared, so that's negative 4 squared, minus 4 times a, which is 1, times c, which is 8. And then that's all going to be over 2 times a, and a is 1. All right, so let's go ahead and clean up what we have here. We have x equals 4 plus or minus the square root of negative 4 squared. Well, that's negative 4 times negative 4. 4 times 4 is 16. and two negatives make a positive. So we'll have positive 16 minus 4 times 1 times 8. Well, anything times 1 is itself, so this 1 isn't doing anything. And 4 times 8 is 32. And that's all going to be over 2 times 1, which is 2. And now let's go ahead and clean up this subtraction here. So we'll have x equals 4 plus or minus the square root of negative 16, because 16 minus 32 is negative 16. If you weren't sure of that, you could always put it in your calculator, don't worry. And then over 2. So you may be noticing a problem here, and that is we have a negative number in our square root, which in ordinary circumstances you would say, you can't do that. So the answer is no answers, right? Well, that's why we have imaginary numbers. So if you don't quite remember imaginary numbers, I also have a video on that. But essentially, all you need to know is that the letter I is the square root of negative 1. So what we're going to do is we can split up the square root of negative 16 into the square root of positive 16 times the square root of negative 1, because 16 times negative 1 is negative 16. And you can do this with square roots. So the square root of positive 16, well, that's 4, because 4 times 4 is 16. So we'll have 4 times, and then the square root of negative 1 is I. So the square root of negative 16 is 4I. So we're going to go ahead and simplify that down. 4 plus or minus 4I over 2. And we can actually simplify this even further. You may notice that this top part, we can divide both of these by 2, because remember, fractions are the same thing as division. So let's go ahead and, just to show this, we'll split this up into 2 fractions. So we have 4 divided by 2 plus or minus 4I divided by 2. Now 4 divided by 2 is 2 plus or minus, and then 4 divided by 2 is still 2, and then the I stays. So if you wanted, this could just be your answer, 2 plus or minus 2I, because you can't combine real numbers and imaginary numbers. So that's it. But you could also write this, because plus or minus, this actually means 2 answers. This means 2 plus 2I, and it also means 2 minus 2I. So if you wanted to write this using the fancier set format, you would say that our 2 answers are, fancy brackets, 2 plus 2I and 2 minus 2I, and then close the brackets. So there you go. This is our final answer, 2 plus or minus 2I. All right, problem number 9. We have 2 problems left. We need to expand x minus 2 to the third. So if you think you know how to do this, go ahead and pause the video, try it, and then unpause and see how you did. All right, so what is an exponent? Well, remember that means you're just multiplying it by itself 3 times. So that's x minus 2 times x minus 2 times x minus 2. Now, you could just do FOIL on these and then do FOIL again on this, and you just have, that would take a while. Maybe it wouldn't take the longest in the world, but you might also have to do problems like x minus 2 to the 7th, and then that's x minus 2, and you're going to be here forever if you try to do that. Which is why we have a great invention from Pascal, and it's in the shape of a triangle. Can you guess what it is? That's right, it's Pascal's triangle. So remember that Pascal's triangle always starts with 1 at the top, and then 1, 1, and then 1's all the way along the sides. But to figure out the numbers inside the triangle, we add the numbers that are above it. So to figure out this number, we take the 2 numbers above it, 1 and 1, and add them together. 1 plus 1 is 2. So this number of Pascal's triangle is 2. And then we do the same for these ones. So 1 plus 2 is 3, and 2 plus 1 is 3. And you can continue with this all the way down, but we actually don't need to for this problem. So we have a 3 here as our exponent, which means that we need to use the third row of Pascal's triangle. But this does not include the row here that's just the number 1. This is just considered the 0th row. And every row after this counts. So this is row number 1, this is row number 2, and this is row number 3, which is the one that we're looking for. So we're going to use this row of Pascal's triangle. So I'm going to move it up here. So how are we going to use this to our advantage? Well, we can use these numbers as the beginning numbers of each term in our expansion. So what we're going to do is, for our first term, it's going to start with a 1. But I won't write the 1 because the 1 doesn't do anything. But we're going to start out with this first part here, all being to the third. So we're going to have x to the third. Now our second term is going to start with a 3, because we have a 3 here, right? So we're going to put 3, and then every term that we have we're going to take away one of the x's and replace it with the second part here. So instead of x to the third, it's just going to be x to the second. We're taking away an x, and we're replacing it with 2, which is our second number here. Our third term is also going to start with 3, right? So we're going to have 3, and then we're going to take away another x. So we had 2 of them, we had x to the second. Now we just have x by itself. And we're going to add another 2. So we're going to have 2 squared. And then our final term is just 1, so I won't write the 1 because 1 doesn't do anything. And we're going to take away that last x, so there's not going to be any x's anymore. Instead, we're just going to have 3 2's, so 2 to the third. Now, you may notice I haven't been putting signs in here. So how do we figure out the signs? Well, if you have a plus here, then all of these would be pluses. So if it's expand x plus 2, it would be plus, plus, plus. But if it's minus, you just have to alternate minuses and pluses. So we'd start with a minus. We'd have x to the third minus this, plus this, minus this. And if you had more terms, then it would be plus, minus, and so on. I know that was a little confusing, so if you need a little more explanation of that, then I do have a video on it that you can watch in the description. So let's go ahead and simplify what we have here. X to the third, you can't really do anything with that, so that's x to the third, minus, and now we have 3 times 2, which is 6, x squared, plus, and now we have 2 squared. 2 squared is 4, times 3 is 12, because 4 times 3 is 12. So we have 12x, and then we have minus 2 to the third, that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we'll have 8 here. And there you go. This is our expansion. That's what it means by expanding. I guess another word for it could be simplifying, because you're simplifying it. But, I mean, do you really want to say that this is more simple than this? I mean, they can get really complicated. So that's why we use the word expand, because we're not going to pretend that this is simpler. All right, you've made it to problem 10 of this video. Congratulations, this is the last problem. And after this problem, you'll know all the main things that you need to know for the Algebra 2 midterm. So for this final problem, we need to use synthetic division to find this. We have a big, long polynomial. That's the fancy name for this, polynomial, because poly means multiple, and nomial means, I think it means names, but that doesn't make sense. I don't know, whatever. It's got multiple things, and then we're dividing it by x minus 3. Remember that there are 2 ways to divide polynomials. We have long division, which can be used to divide any polynomials, but we can also use synthetic division if we just have x plus a number or x minus a number. And synthetic division is faster, but you can only use it in these cases. So what we're going to do is we're going to draw a little box here, and we're going to put whatever number is here with the opposite sign. So in this case, we have minus 3, so we're just going to put 3. And if this was x plus 3, then we would have to put minus 3. And then we're just going to list all of the beginning numbers here. So we have 2x to the third, so it's going to be 2, negative 9, 13, and negative 12. And if you were missing something, like if you didn't have an x to the third, but you had an x to the fourth, then you would just put a 0 there as a placeholder. Then we're going to draw a line all the way through here. And in front of this last number, we're going to put another line here. And this is going to be where our remainder is. So all we have to do is move this number down. So that's 2. Then we're going to multiply it with the number in the box. So that would give us 2 times 3, which is 6. And then we add these up, and that'll give us our next number. So negative 9 plus 6, we lost $9 and then gained 6 back. We're still down $3. Then we have 3 times negative 3. 3 times 3 is 9. And the minus sign stays. 13 minus 9 is 4. 3 times 4 is 12. And then negative 12 plus 12, those cancel out and give you 0. So this is going to be what we use to write our final answer here. But how do we use these? Well, remember, this is going to be our remainder, but we don't have a remainder here, so we're not going to worry about that. This number here is going to be by itself. This number is going to be the x term. This is going to be x squared. And so on. If we had a number here, that would be x to the third. So let's go ahead and write our final equation. We're going to have 2x squared minus 3x plus 4. And now we don't have a remainder, but let me just show you what would happen if we did have a remainder. Let's say that this was 5, for instance. Then we would have plus 5, and then you have to divide it by what we divided by at the beginning. So you would put it over x minus 3. But in this case, we don't have a remainder, so we don't have to do that. So there you go. Our final answer to this division is 2x squared minus 3x plus 4. And there you go. Congratulations. You've now gone through the 10 most important things you need to know for the Algebra 2 midterm. And as I said before, I have links in the description for all of the types of problems that I talked about. So if you got one wrong, then you can go back to those videos and do some practice. So just keep practicing these kinds of problems because practice is the best way to get prepared for the exam. But if you think you have these down and you need to brush up on some of the other topics that are smaller that I haven't talked about in this video, then I have an entire Algebra 2 playlist that you can watch right here. And as always, if you have any questions about this video or any of the problems in it, go ahead and leave a comment and I'll be sure to answer your question. Thanks for watching.